Hi, everybody. Mrs. Fortuna here. Sorry we couldn't be together today. We did have a day off from school, but I would like you to, in the meantime, watch this lesson on dividing fractions with unlike denominators. And today we're going to draw lots of pictures that are going to help us. So I'm going to write on my whiteboard. Please make sure you are writing on your math notebook. Okay, drawing some of the same pictures that I am going to draw today. Okay, so the first problem we are going to work on is 1/4 plus 3/8. Okay, and we're going to draw a model that's going to help us to understand why we have to do certain things when we are adding fractions together. Okay, we're going to draw something called a bar model. And so you're going to make a little rectangular figure on your paper for each one of these fractions. Okay, well, the first one tells us, and so the denominator is 4, and the denominator is going to tell us how many pieces we need to break this fraction up into. Think of it like a chocolate bar. You have 4, you want to break that chocolate bar into 4 pieces. So we're going to go ahead and do that. You can just draw 3 even lines to give us 1, 2, 3, 4 pieces of the chocolate bar. On the other one, we want 8 pieces. Okay, so we're going to draw 7 lines. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Not quite even because I'm using my own handwriting, but you get the idea. They should be even. Okay, so now we have a chocolate bar that's broken up into 4 pieces. And now we have a chocolate bar that's broken up into 8 pieces. So the numerator is going to tell us how many of those pieces you're allowed to eat, for example, or how many of those pieces you're going to shade. So in the 1/4 model, we're going to shade 1 of the 4, 1 out of the 4 pieces. So we just shaved 1. Okay. The second fraction is telling us that we're going to shade 3 out of the 8 pieces. So let's go ahead and do that. 1, 2, and 3. Okay. But when we add fractions together, we need to make sure our fractions have the same denominator. Okay, so I'm going to show you. We want to try to figure out how we can show this 1/4 with a denominator of 8, okay, to match the 3/8 that we have on this side. Okay, and the way that we can do that is we can divide this 1/4 chocolate bar into 8 pieces. Now, right now we have 4 pieces. We can divide it into 8. So we're going to take each one of these pieces. And if you have like a colored pencil, or you're just using a regular pencil, maybe this is where you can draw the lines a little darker. So I'm going to divide each one of these pieces in half so that I can have 8 pieces total. So I divided this first one in half. I'm going to divide the next piece in half, and the next piece, and the next piece. Okay, so now both of these chocolate bars are divided into 8 pieces. Now, so I obviously can keep that 8 for my 1/4, but I need to know what the numerator is going to be. So the way I find out what the numerator is I look and see how many pieces are shaded in my chocolate bar. Well, I still have 1 shaded here and 1 shaded here. Okay, they're still the same amount that is shaded. So that tells me there's 2 shaded parts out of the 8. Okay, so that's how I can turn that 1/4 into 2/8. We're just going to make some smaller pieces there. Okay, and they are equal. Remember, I didn't shade any more pieces here, and I didn't make the chocolate bar bigger. I just divided them up a little bit more. Okay, so that's why we can say 1/4 is equal to 2/8. Well, now I can go ahead and do my addition. Okay, so when we are adding two fractions with similar denominators, we're going to keep that 8 at the bottom because that's the same. And then we're going to go across and add. So 3 plus 2 is 5. Well, let's see if that's true. Is this true? Let's go back and see. Well, we can look at our bar model here to see if our answer was correct. So we know for sure that there is 8 pieces in one chocolate bar. Absolutely. Now we want to say, go back and see, out of all the shaded pieces, is there 5? And that was the answer we got, right? And we know that the numerator represents the pieces that are shaded. So we have 1 shaded piece here, 1 shaded piece here, 1 shaded piece here, 1 shaded piece here, and 1 shaded piece here. Well, look at that. 1, 2, 3, 4, 5. Perfect. Our answer is correct. All right, let's try. If you need to pause this video to make sure that you have this on your paper, go ahead and do that. I'm going to move on to another one. Okay, so now we're going to add another problem together. But in this problem, we already have a problem right from the beginning. We have 2 denominators that cannot so easily be that we need to make the same, just like we did in the last problem. Okay, and in order to find out what our denominator is going to be, we need to find the common multiple. Repeat after me. Common multiple. Excellent. Okay, so the way we find the common multiple is we're going to find what the number is that both of these, when we put both of these numbers into a multiplication problem, what is a multiplication problem that these two have in common? Okay, so first we're going to start by listing multiples of 3. Usually it's best to just start with 1, okay, and keep going down the list. Maybe list 2 or 3 problems and then stop and then come over to the other one and list a few problems here. Okay, so we know 3 times 1 is obviously 3. 3 times 2 is 6. 3 times 3 is 9. Okay, so I listed a few for 3. Now let's list a few for 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. All right, we have found it. We have found a product that is the same for 3 and 2. It is 6. When you multiply 3 times 2, it's 6. And when you multiply 2 times 3, it's the same problem, just reversed, right? Also 6. So great, we know that the number that these two have in common, the common multiple between 3 and 2 is 6. Okay, so now we can go ahead and draw ourselves a bar model like we were in the other problem. So we are going to draw 2 bars, just like we did last time. Imagine that chocolate if you would like. Okay, this bar is going to represent 1/3. This bar of chocolate is going to represent 1/2. Okay, but we need to divide. We need to have 6 as our denominator. Okay, because we need to have a common denominator. In order to add things together, the denominators need to be the same. So we can go ahead and divide this. Well, actually, let's go ahead and start by dividing it into thirds first. We're going to divide it in this. So we're going to go 1 and 2. So now we have 3 pieces, right? And we're going to shade 1 of the 3. Okay. This one, we're going to divide it in half. So we have 2 pieces because that's our denominator. then we're going to shade one of the two pieces. Then the next thing we're going to do, now we can divide things into sixths. So we're going to take each of these three and divide them in half. So we're going to draw a line there, a line there, and a line there. We're going to do the same thing for the 1/2. We're going to divide the 1/2 into 6 pieces. So there's one piece there, two, keep this here. Do that right? Ooh, no, I need one more line up here. So now we have 1, 2, 3, 4, 5, a little tiny piece there, and 6 pieces there. Okay, well, now that we've divided it into 6 pieces, we can figure out what our numerator is going to be on both problems. So 2 pieces are now shaded right here, 1 and 2. So we know this 1/3 can turn into 2 over 6. We have the 1/2. We know that 1, 2, 3 of the pieces are shaded. So now we have 3, 6. Well, perfect. Now we have 2 6s and 3 6s that we can add together. Okay. Pause if you need to finish writing this down. I'm going to erase so I can add these two together. So we have 2/3. I'm sorry. 2 6 plus 3 6. Perfect. So we know we can keep, now the denominators are the same. We can keep that there. And then we know 3 plus 2 is 5. Yay, we were able to add it together. All right, let's try a fraction. Let's try another one, but in this scenario, we are not going to draw any models. Okay, so we have the same scenario here where we need to find a common denominator. So we're going to take 4, which is the denominator we have now, and we're going to take 3, which is the denominator we have on the other problem, and we're going to list the multiples of them and find which one is the common multiple. Okay, so let's write 3. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. All right, let's write a couple over here. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Do we have a common multiple yet? No, I don't think we do. All right, let's keep going. 4 times 4 is 16. Let's just add one more on each side. 3 times 4 is 12. Do we have a common multiple now? Yes, we do. There it is, 12. I got a 12 on both sides. Okay, so now we know that we can make 12 our denominator. So let's see. Okay, friends, sorry about that. All right, so we know that our denominator for both of these problems is going to be 12. Okay, so 3 over 4 equals something over 12, and 2/3. And I'll just, if it helps, I'm going to draw a line down the middle. So, you know, we're looking at 2 different problems here. 2 over 3 or 2/3 is going to be something over 12. Okay, so another way, instead of writing a bar model every time, because that might take us a little bit longer, is to multiply the numerator and the denominator by something to give us the new numerator, okay, so that we can add this and this fraction together. Well, we know that 4 times, so we know we can go ahead and fill in, we're going to multiply this 3/4 by a fraction, and we're going to multiply this 2/3 by a fraction. Well, we already know that 4 times 3, because we figured that out here, right, is 12, okay? Now we're going to go ahead and take that 3 and we're going to multiply it by this number. Okay, we're going to use the same 3 that we have here to multiply by this number. We have 9. In essence, we're going to multiply because this equals 1 whole. 3/3 equals 1 whole. So we're going to multiply this 3/4 times 1, and that's going to give us 9/12. Okay, so we know that 3/4 really is equal to 9/12. We'll bring that down here so that we can add it together. Okay, we're going to do the same on this side. So we know, see this, aren't we glad we learned division? We know that 3 times 4, right, equals 12. That's what we figured out earlier. So we're also going to take that 4 and we're going to multiply 4 times 2, which is going to give us 8. Okay, so now we have 8/12 plus 9/12, right? So then we can go ahead and add them together, 17/12. Oh, but wait a minute. The number on the numerator is larger than the denominator. So now we're going to ask ourselves, how many 12s are there in 7? Are there 2 12s in 17? I'm sorry, not 7, 17. Are there 2 12s in 17? Well, no. 12 plus 12 is 24. That's too many. So we're going to simplify by saying there's only one set of 12 that can go in a 17. After 12, we are going to have 13, 14, 15, 16, 17, 5 left over. That will give us 1 and 5/12. Okay. If you don't get to this part where you're simplifying it, that's okay. It's really important that we just add fractions with like denominators. And so multiplying them, finding the least common multiple, and then multiplying them by 1 is a great way to do that. Okay, friends, I am going to put a problem up. I would like you to see if you can solve this one by yourself. So pause this video and see if you can solve this. Okay, you can use the bar model or you can multiply by 1. Either way would work. So pause. All right, now come back to the video and let's go ahead and solve this problem together. So of course, we need a common denominator between the 5 and the 3. I'm going to go ahead and use the bar model because that's one's easiest for me. So we need to find a common multiple of 5 and 3. So I'm going to go ahead and draw a bar model for 1/5. Okay, I'm going to divide this into 5, 1, 2, 3, 5 equal parts. Then I'm going to shade 1/5 of it. Then I'm going to draw a bar model for 2/3. I'm going to divide it into 3 equal parts. Then I'm going to shade 2 out of the 3. Okay. Well, we know that 5, well, you know what? This may not be the best way to do this. I'm actually thinking I'm going to go the other way because I just realized that 5 and 13 do not have are not multiples of each other. Well, no, I guess they are. We could have done the bar model. That's all right. I'm going to go this way. All right. So we need to find the least common multiple of 5 and 3. So 5 times 1, 5 times, I'm going to do 3 of these, 5 times 3. So 5, 10, 15. Okay, let's find 3. 3 times 1, 3 times 2, 3 times 3. 3, 6, 9. Do we have a common multiple yet? Nope, nothing yet. Let's keep going. 5 times 4, we'll add just one more on each side, is 20. 3 times 4 is 12. Anything yet? Nope, nothing yet. Let's do one more. 5 times 5 is 25. 3 times 5 is 15. Do we have one? There it is, 15. Okay, so we know that 1/5 times something over something is going to be equal to the denominator of 15. So that's the problem for that one. Now we're going to do the same thing on the other side. 2/3 times something equals something over 15. Okay, well, we know 5 times 3 is 15. So we're going to take that 3 up here and 3/15. And then we know that 3 times 5 is 15. So we're going to bring the 5 up here. 5 times 2 is 10. So now we have 3/15 plus 10/15. Okay, and we know 10 plus 3 is 13/15. Hopefully you got that. All right, guys, that's my lesson today on adding fractions with unlike denominators and draw pictures. Remember, we can draw bar graphs like we did earlier and divide them up that way. But most importantly, we need to make sure that when we're multiplying two fractions together, they have to have a common denominator, no matter how you do it. So you can write out lists of the multiples and find out which one is similar. And then we're going to go ahead and multiply by 1 on each side, which will give us two fractions with the common denominator, and then you can add them together. All right, I will see you all next time. Bye.